All right. Can everybody hear me?
Yes.
Good. Thank you. All right. So welcome to the 2025 Python Bootcamp in preparation for our CompuCell workshop. Thank you everybody for bearing with me on the slightly delayed start this morning. Um, I'm feeling a little bit under the weather today, so you'll have to, um, again, just bear with me. I think we'll be able to get through most of this. On the topic of weather, Indiana is also expecting some very bad weather um, later this afternoon at around 2 or 3 o'clock, I think. We're supposed to get some pretty bad storms with 50-mile-per-hour winds, so there is a chance that I may lose power later in the day today. If that's the case, we will make sure to do a recording of any of the content that we don't finish today and upload that as soon as possible, first thing next week. And we'll make sure the links go out to everybody for that. Just to give you a heads up there, if we suddenly lose connection, don't worry, we'll make sure the rest of the content goes out at the end of the weekend. All right, so just a couple of notes up front here. This session, as well as most of the sessions for the workshop, is being recorded. Today we are not currently being live streamed. That may change if Dr. Glazer joins the meeting in a little bit, he might start the live stream. But for right now, we're just recording. Again, we'll make sure that these recordings go up to YouTube so that people can view these sessions later if they need to. This slide deck can be found in our student materials folder, which I will get a link to here and put this in the chat. You can find it in the module slides folder. There was a folder labeled day 0. This is our day 0 is how we refer to our Python workshop. So you can find the slide deck there. Slides for the next 2 modules will go up during the lunch break. Please submit any questions, concerns, or suggestions you have via the Zoom chat. I will be taking short breaks periodically to monitor that. So if you have any questions, please feel free to throw them in there. Try to respond as quickly as possible. You can also use the raise hand Zoom reaction if you have something urgent that you need to ask, if it looks like maybe something got missed in the chat. We also have a Slack channel set up for the workshop, just as a reminder. So let me put this link in the chat as well. If you have not signed up for the Slack workshop, we recommend you do so before the workshop starts. It's a good place to talk to your fellow workshop mates and potentially look for hackathon project group members if you're interested in participating in this year's hackathon. If you have not installed CompuCell3D on your computer yet, I know I saw in the chat there was one question, somebody saying that they have installed, but unable to open it. If you are having issues with your CompuCell installation, please email me as soon as possible so we can set up a meeting sometime this week, a one-on-one to help you troubleshoot your installation. For today, we have a couple of ways to work around that. We will not actually be using CompuCell proper today, but you do need to have Python installed on your computer, which if you've installed CompuCell, you have Python installed on your computer already. So we'll talk about that here in a few slides about making sure everybody has what they need for today's session. We'd like to thank our funding sources from the NIH and the NSF. Their funding allows us to put on this workshop each year, so we are appreciative of their support each year. Okay, so I think we can go ahead and get started. Just a quick overview of what exactly we'll be doing today. So we are, like I said, getting off to a slightly late start today, but that's okay. We will make sure that we make up the time before lunch. From now until noon, we'll be having our first module, which is sort of just a very brief crash course on an introduction to a number of different basics in Python. Excuse me. My camera's out of focus. Coughed so hard the camera went out of focus. From noon to 1, we'll have our lunch break. We'll come back at 1 o'clock for module 2, where we'll be probably finishing up a little bit of the content from module 1, and then we will actually have a sort of practicum. We're going to be doing a little Python model building exercise. We'll be programming a blackjack game together to kind of put to use some of the stuff that we talk about in module 1. From 2:30 to 3, we'll have a half-hour break. Then from 3 to 4:30, we'll have our third module, which is some additional Python topics, some things that you'll need specifically for using CompuCell. And then we'll take a look at what Python actually looks like in CompuCell before we break for the day. From 4:30 to 5, we'll have Q&A. I do have a little bit of a hard out at 5:15-ish today. My wife and I are going out for an anniversary dinner at 6:30, so I need to be able to change and get ready for that. But we will be available throughout the next week to answer any questions via email. If you're having any large or serious concerns about things maybe that you didn't understand from today's boot camp or anything additional that you'd be interested in learning, please do email me. And again, we can either communicate via email about that, or we can set up a one-on-one time to actually meet and talk through some of the material. So please don't hesitate to contact me if you are having issues finding resources on what you'd like to learn in Python. All right, so our learning goals for this first module, again, we're going to go over basic Python syntax, in other words, how to read Python. We'll talk about some basic operations in Python, how to use mathematical operators, and various things that kind of form the foundation of programming. We'll talk about variables and data types, as well as control flow. So this is a fancy term the programmers use to refer to kind of decision making throughout the course of a program. So we'll talk about if-else statements, we'll talk about running loops, and we'll talk about logic and conditionals, break statements, a lot of different things, kind of that control the flow of the program. We'll also talk about working with sequences, so things like lists and strings, data types that are indexed, how to get information out of a sequence, how to split them up into smaller sequences. And then we'll conclude module 1 today before lunch with talking about how to define your own custom functions in Python. So we're going to move a little bit quick today. Don't worry too much if we get to something that you're not super familiar with and we move a little bit too quickly. The purpose of today's session is mainly to introduce you to the very basics of Python so that you can participate as completely as possible in the workshop, because we do use Python code to build CompuCell simulations. So you don't need to know a lot of Python to work with CompuCell, but there are a few key topics that you will need, and we'll touch on all of those today. So again, if you'd like to learn more about anything in depth and you're having trouble finding resources, please do contact me and we can point you in the right direction there, or potentially meet to discuss further, like I said. All right, so very quickly, why do we want to learn Python specifically? Now, I just said a minute ago that CompuCell uses Python. That's the main reason. But there are a couple of other reasons why Python is used in CompuCell and why it's so widely adopted across the scientific computing scene, so to speak. So specifically for our workshop, we'll be talking about using Python for reaction network design and analysis. We'll be using it primarily to add behaviors to model biological cells. In CompuCell, this comes in the form of working with steppables. These are basically chunks of Python code that are run in between each chunk of Monte Carlo steps. So the simulation will run something like 10 Monte Carlo steps, and then it will stop and run the Python stepables to update um, the code. So the stepables are actually what's causing your simulation to change over time in CompuCell. And that's all handled in Python. And it's also very useful for analyzing data from experiments. So there's a lot of different Python packages and modules that you can use for visualizing data, making plots, doing data analysis and optimization. We won't talk in too much detail about those packages today, but we will cover some of that during the workshop. Other reasons, Python is a convenient, widely used language that works well for all of these tasks. There's a lot of support available for Python, and everything done in Python is completely open source for the most part. So it is easy to find pre-existing tools typically for more or less anything that you need to do with Python. Maybe I should be careful there. It's not always easy to find what you're looking for, but somebody out there has probably already done it in Python, and you can usually find something close to what you need through public repositories online. One final note, we'll use programming a little bit differently today than we will during the workshop. Today, we're going to be talking more about traditional approaches to programming, but when we talk about programming a simulation in CompuCell, that will look a little bit different, and that will become more clear over the course of the first week of the workshop. You won't need to be doing as much of the kind of base level programming stuff that we're going to talk about today in CompuCell, because a lot of it's handled through our code insertion plugin menu, where you can kind of have it generate some pre-existing code for you, and then you change the parameters as needed. But for today, we're getting you familiar with programming if you've never programmed before, and then specifically with how to do sort of simple common tasks in Python. Apologize. I will try not to have to cough after every slide. Hopefully that will get better as we go. Yes, so I think that this kind of covered in the previous slide. Again, we'll be learning the necessary programming concepts to build, study, and analyze advanced models in CompuCell3D. So some notes about keys to success in general with programming. Again, if you've never done programming before, sometimes it can feel a little bit intimidating because it seems like there's an infinite amount of information to take in on the topic, particularly if you were trying to crawl the internet and find the information you need. Sometimes it can be very difficult to get pinpoint help where you need it. So just keep in mind that nobody knows everything about everything related to a specific programming language. Obviously, there's various levels of expertise out there, but in software, there's almost always something new to learn. Even the most advanced programmers can't know everything about a language, especially a language as broad as Python. At least once today, we'll probably come across something that I don't know. That's okay. That's a perfect example of what I'm talking about here. But the biggest thing is if you don't know something, just look it up. A coder's best friends tend to be, there's usually manuals for any module or plugin package you'd like to use in Python. Developers will put manuals out, so you can usually find official documentation of the packages online. I will say that those tend to be of varying levels of useful help. Sometimes they're very programmer oriented, and sometimes they have instructions for beginners as well. But if you're having trouble with the manuals themselves, other coders often are very helpful. Sites like Stack Overflow. Usually there's, for packages that are distributed through GitHub, you can submit questions and tickets through the GitHub page. And then there's usually debugger menus, depending on what kind of IDE you're using. If you're using an IDE, there's a lot of different sources out there. So don't hesitate just to look something up if you're unsure. You can usually find a solution that's fairly close to what you're trying to do. It may require a little bit of adaptation to your specific problem. Um, but even the most expert coders spend a lot of time looking things up throughout the day to get help on what they're trying to do. The other thing to remember is solutions in programming are almost never unique. For some of the early examples we'll do here today, things will be pretty basic, but once we start getting into some of the exercises in the later part of the day, there's numerous different ways to approach each problem. There's not necessarily a correct way to do things in programming. So focus on what you want to do and try to get that solution realized as best you can and experiment with different ways of how you do it. Like I said, there will be multiple ways to approach a problem. So don't feel like you're doing it wrong necessarily. There are certainly more optimal ways and more computationally efficient ways of solving a problem. But for today, just focus on trying to implement your solutions the way that you think makes the most sense. And the number one key to success is perseverance. Again, don't worry too much if you feel like you might be getting a little bit lost today. It is going to be a lot to take in. So just follow along as best you can. And like I said, if you need help, additional help before the workshop or even after the workshop, if you'd like to meet to brush up on some skills, we are here to help with that. And I think that's it for that. So one thing before we get started, we want to make sure everybody is ready with the tools that we'll be using today. We'll be doing today's tutorial using IDLE. IDLE is a programming environment that comes standard with all installations of Python. So if I could get a show of hands, you can put your response in the chat as well if you don't have access to the hand raise reaction. Who has installed CompuCell already on their computer? Okay, it's looking pretty good. I know we have a couple people saying that they were having issues launching CompuCell. We can meet to debug that later, but if it installed, even if it's not running, you should still have Python on your system. CompuCell not running may be an issue with something else. Okay, so let me share my whole screen here. All right, so it looks like pretty much everybody has CompuCell installed, which means you have Python. So if you install, there's two ways to get to IDLE depending on how you installed CompuCell. If you installed CompuCell3D using the installer package, so if you went to our website, downloaded for Windows, it would be the .exe. If you're in Mac or Linux, if you installed using the .sh file, then you should just be able to open in Windows, it's your start menu, and search for IDLE. I think in Mac it's called Launchpad. And you should have this IDLE app here. So if you install it using the installer, you can just click on IDLE. It should launch. And you'll be given a interactive Python prompt. We'll go over how to get to it if you installed via Conda in just a minute, but I want to make sure everybody is able to open this. So if you installed using regular CompuCell installers, are you able to get to the IDLE shell? So go ahead and if you can, let's do it this way. If you cannot get to the idle shell, raise your hand just by searching for it on your computer. Okay, so for those not showing up as an app on Mac. So Katerina, yes, if you have Jupyter Notebooks set up on your computer, you can use Jupyter Notebooks. That'll be fine. Okay, so Ellen is telling me on Mac the install is through Miniconda. Okay, so we'll look in just a second on how to do that. All right, so if you installed CompuCell3D through Conda, which Mac and Linux, I believe, do, then you'll have to launch your Anaconda prompt. So we'll do that here. Mine has all this junk in it because my Anaconda is tied to CompuCell. And then, sorry, I do split screen here. So you'll launch your Anaconda prompt through either your start menu in Windows or again your launch. I think it's called. I don't use Mac. I believe it's called Launchpad in Mac when you just search for something and launch it on your system. Um, you'll start with your base Conda environment, and then what you'll need to do is activate the Conda environment that you created when you installed CompuCell3D. Um, so you can view your environments in Conda by doing Conda env list. It's Conda environment list. Sometimes it'll take a second to populate. So for me, I only have base and TF workshop, but you should, if you installed CompuCell through Conda, you should have one that I believe is called um, CC3D underscore 470 underscore 310, something like that. It might be 460, depending on which version or when you installed it. So you would use conda activate environment name. So whatever this CompuCell is, activate that. This will change from base to your environment, and then you should be able to run idle by just typing in, once you've changed your CompuCell environment, if you just type idle, press enter, you should be able to run it that way. How do you find Miniconda on Mac? Are there any Mac users in here that could help with that? I believe you just search for Anaconda prompt. Or yeah, so you just launch a terminal. All right, so it looks like that's working for Mac users. Okay, who is still unable to get to idle? Um, Ripla, is that a new raised hand or am I looking at an old one?
Still can't figure it out.
Okay, are you on Windows or Mac?
On Mac, so I tried the command and it says no module named idle lib.
Okay. Lorenzo, would you be able to take 2 minutes to walk people through the Mac? Because I don't have the Mac interface to show people. Ava, yes, you can also just so what Ava is saying here in the chat is if you to close idle first. In your mini conda prompt, you can also just run Python. It'll give you the interactive prompt in the terminal. So you can also do it that way. Sorry. Looks like most people are able to get idle running. I know a few people are still working on it. We will try to continue helping you in the chat. If you need to move to a breakout room, I'll open a couple here. Do not actually, sorry, do not join breakout rooms. I didn't realize that was going to send invites. Sorry about this. Okay. So we have breakout rooms open. If people need to move to one, please let us know in the chat if you're still having trouble. We'll try to get idle set up for you. If you're not able to get it working, um, please just follow along for now, and we can try to get you up to speed during the lunch break. We have some potentially alternative methods as well that we can get you running during lunch. Okay, so once you get idle launched, you should have an interactive shell like this. Um, this interactive shell allows you to type in basically individual Python commands one at a time and see the evaluated output. We'll start going over that in a minute. But you can go ahead and type expressions into the shell prompt. So let's try typing some mathematical expressions together. So if we do, for example, 3 plus 2, and press enter, you'll see it evaluates out to 5. Do 7 times 4, get 28. We can do basic things like printing to the screen with our command print. And then we'll just stay very stereotypical here and do our hello world. So this allows you to evaluate commands one at a time. Um, and if you want to take a minute to experiment with your idle shell, let's say given two positive integers a and b, find the integer corresponding to the sum of a and b, then find the product of a and b. So just take a minute and make sure your shell is working correctly, and we'll move forward in maybe 1 or 2 minutes here. We've got some basic operators here, plus, minus, divide, multiply. Has anybody tested this double asterisk yet? Anybody tell us what that one does? So Harini says square, Troy says exponents, yes, it's to the power. So two asterisks is 2 to the power of 3. So in this case, 8. Um, good. All right, so it looks like basic calculations are working, and we'll show you how to actually open up a code file here in a little bit. For now, we're just going to stay in the interactive terminal. Once we start doing loops and things like that, the interactive terminal gets cumbersome because you have to type it in fresh every time. So we want to be able to run reusable code. All right, so we've just used scalar types. Um, so programs manipulate objects. Um, Objects have a type that defines the kinds of things programs can do to them. If we get to it later today, we'll talk a little bit more about some of the concepts of object-oriented programming. For now, it's important to understand that each thing that you interact with in a program is an object that has a type. So, for example, Anna is a human, so she can walk, speak, etc. There's two types of objects, scalar, which cannot be subdivided, and non-scalar objects, which have internal structure that can be accessed. So if you think of like a number, like 1, 2, 3, 4, those are scalars. They just have a single value associated with them that can't be split apart. But if you think of something like a string, so up here when we printed hello world, um, let me actually make this font larger so people can see that better. When we printed hello world up here, this is referred to as a string. So this is a string of individual characters. These are non-scalar data types because the string has to keep track of all the letters and the order of the letters in the object. That'll become more clear as we do some examples here. So again, scalar types that are common in Python, we have integers representing whole numbers. So like I was saying, 1, 2, 3, 4, 73, 89. Whole numbers with no decimal point. Float scalar type represents real numbers. So these are decimal numbers with decimal point accuracy, things like 5.1. We also have a special kind of scalar type called a Boolean, which is a true false object that just contains the property either true or false. So it's 0 or 1, on or off. Um, there's one called the none type, which we won't be using today, but it's still useful to know about. It has one value, which is none, if you're familiar with. Other programming languages like Java, sometimes this is referred to as null. It's kind of the same idea here. Um, if you're not sure about the type of an object, you can get the type um, by just using the type function. So if we do type 5.1, it'll give you which class it belongs to. So if we do type 6, you'll see int. And then if we do type example string, class string, so on and so forth, type. Now, if we do this, we'll get an error. The reason for that is because Boolean values specifically have to be capitalized to be recognized as a true false Boolean. Um, so in this case, what Python is telling me is that I've tried to basically type the string true, but it's taking this as a variable name, um, which isn't defined. So now if we do type true, and you'll notice in idle the color changed there because it's recognizing the reserved word capital T true, we'll get class bool. Same thing with type false. But if we do type and we use quotes, this is how strings are represented. That'll get parsed as a string. So again, if you're not sure what a variable is type-wise, you need a program to verify it for you. We won't really be needing to do that much today, but once you get into kind of large-scale programming, sometimes it is useful to be able to print out what the type of a variable is, particularly for debugging if something's getting um, interpreted incorrectly, it can be very useful. In Python, you can convert types on the fly. Not all programming languages let you do that. Things like Java, if you've used Java before, you have to specify the type of every variable when you instantiate it, and it can't. You can reassign the variable name, but the type can't be changed or cast into another type. But say, for example, we have um, a float of 5.1 and we want to turn it into an integer data type. What that'll do is basically chop off the decimal and just leave the whole number. And you do that just by putting the type you want to cast it to in front. So if we do int 5.1, we'll get printed out 5. Alternatively, say for example, we have an integer value that we need to turn into a float. Certain methods will only take float numbers as parameters and vice versa. So if we do float 5, you'll see it casts it into a float by adding a 0.0 to it, which will allow it to be used as a float. So you can freely change variable types using this cast function in Python. So some more terminology here. Expressions are bits of code in Python that combine objects and operators. So an expression has a value. So this is what's actually being evaluated when we run each of these lines. We have an object, an operator, and another object. So our mathematical operations that we were doing up here to test can be considered very simple expressions because they have two objects and an operator in between them. And we can run more complicated expressions using our interactive terminal. So we used our power earlier. We'll just go ahead and evaluate the one that's on the screen here. And you should get, the value here. So you can do a lot here. And again, these parentheses is order of operations. So it evaluates 5 to the power of 2, 2 to the power of 2, adds them together, and then raises the whole thing to the power of 1/2. We've covered a couple of our operators already. Something to note here is that if both data types are integers, the result is an integer. If both are floats, the result is a float. So if we do 5.5, or excuse me, 5 plus 5, we get an integer value out. If we do 5.0 plus 5.0, we'll get a float value out. Can anybody tell me what happens if we add an integer and a float? And feel free to test it in your terminal. You get a float, right? So in this case, floating point numbers have priority here, so it casts the integer into a float when it adds them together because the data types have to be of the same type to have operations performed on them. You can't add an integer and a float together directly. If anybody's worked in Java or C, you know this very well. It can't be. You can't add the two together without converting one first. Excuse me, I have to. There's one other operator we haven't talked about yet. This, what's called the modulus, sometimes referred to as modulo operator. And what this is the remainder when I is divided by j. So if we do 10 modulo 2, we'll get a result of 0 because there's no remainder. 2 divides cleanly into 10. But if we do 10 modulo 3, we have a remainder of 1. And this becomes useful in certain cases, one of which we'll actually look at in a minute. So again, just a quick note on order of operations, operator precedence. So parentheses take precedence over everything else. Whatever is in parentheses will be evaluated before other operators, and then it moves according to normal order of operations rules. So parentheses first, power, multiplication, division, plus and minus, and then it's executed left to right as it appears in the expression. Relatively straightforward. So again, in this case of the 5 to the power of 2, it would evaluate 5 to the power of 2, 2 to the power of 2, add them together because they're in parentheses, and then raise the whole thing to the final power. So far we've just been working with kind of real-time values. One thing, obviously, that's very important in programming is creating variables to store information for later use. In Python, we use a standard equal sign as an assignment of a value to a variable name. This value is then stored in the computer memory, and then you can retrieve that value just by using the variable name before. So we can actually do this in our interactive terminal still. So we can say x equals 5. When you press enter, you'll notice nothing gets evaluated to the screen. But now, when we just reference x, it'll print out 5 for us. We can change that value. We can do x equals 7. And then when we evaluate x, we'll get 7. We can also print this traditionally using a print statement. So before we printed hello world with quotes because it was a string that we hadn't stored yet. But if we just print x, you'll see it prints out 7. And then if we wanted to maybe store a string, we can do that too. So we can do hi equals hello world. And then when we print hi, which is our variable, we get hello world out. And again, we can check our type of our variable now by using the type function and putting the name of our variable in. And again, we'll get class string. Relatively straightforward. Any questions about that so far? I know if you've never done any programming before, this is all pretty new, but hopefully not too complicated. Okay, so like I said, we can change the values stored in variables. That value does not change again until you tell the computer to change it. So here we have basically a basic calculation of radius, um, where pi is set to be a certain value. So we can actually just do this in our terminal. We'll do pi equals 3.14, radius equals 2.2, area equals pi times radius squared, right? Pi r squared. And now when we press enter for area, what we can do is print area. It'll print out our area for us. Radius equals radius plus 1. So this is going to increase our radius to 3.2, which we can print to check by printing out radius. So it did increment it. So here, this is what's referred to as an incrementer function, where you do radius equals radius plus 1. So it's referencing the variable itself, adding 1, and then restoring the value in the same variable name. And now if we do print area, you'll notice we have the same value coming out, even though we've changed our value of radius. So the reason for this is because we're in an active prompt. Area has already been set to a value. And even though we've changed the value of radius, the area variable is not being updated actively. So what we would need to do is run this again. I can say again, sorry. Radius power 2. Now when we print area, we'll get our increased value. So this is a good point to switch to actually using code files because we're starting to see some of the limitations of the interactive prompt. It's very useful for testing small things here and there. And what's interesting about it is you can use it in conjunction with a code file. You can actually run things in the interactive prompt that do not happen in your code file. So what we'll do here is if you go up to your idle shell under File, we want to open a new file. And this will just give us a blank code file. And so what we can do now, so one thing I do recommend, if you go to Options, Show Line Numbers, this will be crucial in helping to debug later. What we can actually do is now that we have a code file, so this is a Python file, .py, we can type the same thing here. So we'll do pi equals 3.14, radius equals 2.2, area equals pi times radius to the power of 2. Radius equals radius plus 1. What I'm going to do here is I'm going to leave a comment behind this. What a comment is it's a piece of text in your code that does not get evaluated by the interpreter. The way to do that in Python is just to put in a hashtag, and you'll notice that it codes it in red here for us in idle. And I'm going to make a note here that another way to do the incrementer is to do radius plus equals 1. We'll look at that in another example coming up. But you can also do it this way. Sorry, it equals plus. Just do plus equals. So what we'll need to do now that we've got that typed in, is we need to save our code. Code can only be run if it's been saved to a location on your hard drive. So we will save as. I'm just going to put this on the desktop for today. And I'm going to do so I call this module 0.1 examples 0.1. So now that it's been saved, we can come up to run and we can run the module up here. So what this is going to do is it's going to send this code file to our Python interpreter, and it's going to run each line one by one and print out any relevant outputs. So if we do run module, we'll notice that nothing actually seems to happen. So it ran our module, but there's been no output. And now it's given us a new interactive line. So a difference here is that when we're running in the interactive prompt, each line is evaluated at the time of submitting the line. When you're running a code file, it suppresses outputs unless you specifically asked for them. So here we have to say print area. Then we can do the same thing here. So now we'll save. We'll run our module. You'll notice we have the same issue that we had here, where the values are the same. That's because we have an updated area. So what we can do is just copy, paste, again, save. And now when we run the module, we get our output out. Is everybody following along so far? Any questions about that? About sending code files to the interpreter? Okay. So I'm going to pick up the pace just a little bit here, getting a preview for what to talk about. All right. And again, we will go to lunch at noon. We'll come back and finish the rest of this module after, then have our activity. Moving a little bit slower so that people had a chance to catch up. It looks like everybody has idle working now. Thank you everybody for the help in the chat with that. And I will, when we go to lunch, I'll make sure to put any of the code files that we've worked on in the student materials drive, so that you can go download those if you are a little bit behind. You can just pull those up and run them with your terminal. All right, so I would like a fresh idle shell. Unfortunately, with idle, there's no way to clear all this text off. So what I'm just going to do is you'll see you can close your idle shell, your text file stays open, and then you can just run it again. There's not really an issue with having a lot on the screen. I think it just makes it harder to read instruction-wise. So if you had trouble getting idle open, don't close it. I just might do that periodically to get a fresh screen here. Talked a little bit about strings already. We did our hi, hello there. One thing, again, these are enclosed in quotation marks. You can also use single quotes. I think generally standard formatting is quotation marks, but single quotes work as well. You can concatenate strings. So let's go ahead and don't think Yes, so we have a useful function in idle where you can highlight a block, and if you go to format, you can comment out the region. So that'll add double hashtags in front of everything so that this doesn't get run along with our what we want to do next. So let's just walk through this really quickly. We can concatenate strings. So let's say we want to make the name Anna. We want to make a greeting, which equals hi plus Anna, excuse me, hi plus name. And then what we'll need to do up here is actually put our hi in, because if we tried to run this now, it would tell us that hi is undefined. Sorry, getting ahead of myself. Greeting equals hi plus, and then what we want to do, so if we evaluate this now, well, we can actually just do that. So let's say print greet. If we evaluate this now, so we save, we run our module, you'll see we've got hello there, Anna, no space. So we need to actually manually add in a space. Windows 11, Windows snaps is a little overactive sometimes. Ready to close this shell. So let's get rid of that. And then we want to do a greeting equals hi plus, and then we can add a space in quotes plus name. Now, if we print greeting, you'll see that we get our space. So when you're trying to print out strings that are a concatenation of multiple different things, you'll need to kind of do some of that formatting yourself if you want it to look pretty. We use that sometimes for um, formatting output to the user, especially during debugging, can help. You can also add in, so let's try, if we want to add, let's just say 5 at the end. Let's want to add an integer. Save, see what happens when we run. You'll notice we get an error because you can only concatenate strings to strings. You can't concatenate ints. But like we talked about before with our typecasting, we can actually just turn this into a string this way. And then when we save and run, you'll see we can add our string there. Or sorry, our integer that way. So again, if you're trying to print out a string that's a concatenation of multiple things, everything that's concatenated in has to be either string type or it has to be cast as a string type. So keep that in mind. We have a question here. Can we access slides for today's later modules? Yes, those will go up during the lunch break. I found a couple of things I need to fix before our second module, but yes, I'll put the modules for sessions 2 and 3 up during lunch. All right, so we talked about that already. Talked about printing stuff to the console. Um, Comparison operators. So this is another thing. This is once we start getting into loops. So this is where our logic comes in. This is used to compare variable types, and these evaluate out to true or false values. So we have greater than or equal to. This is supposed to be less than. That's a typo. Less than or equal to. And then our double equals is our equality test. So if I is the same as j, comes back as true. If it's not the same as j, comes back as false. And then we actually also have an inequality test, which is exclamation point, sometimes referred to as the bang symbol in certain programming circles. So we have bang equals um, I and j, and this tests if they are not equal. So if I is not the same as j, this evaluates as true. If it is the same as j, it evaluates as false. So let's just say I equals 5, j equals 7. So now if we do I equals j, we get the Boolean value false. We do I not equals j, we get the Boolean value true. And this will be kind of the foundation of our loops and if else statement logic. I have a slide here about logical operators on Boolean values. This is a little bit um, uncommon with looking specifically at Boolean variables, so I think I'll skip this for now. But if you need to look at this table and see how Boolean values evaluate out when you use operators, you can take a look at this later. All right, any questions so far? How are you running Python in the idle shell? So do you mean how am I running my code file? So I have my Python file here, right, in the window. So to get that, we do file, new file. And then in your Python file, you go to run module, or you can use the F5 key and it'll run it in your shell. If you're using your command line interactive shell, you can just run the Python file by pointing to the path. I'm not sure if that answers your question, Ava, but I'll circle back around in a minute. So Joanna, do you always have to make a new file for the interpreter? Um, I'm not entirely sure what you mean by that, Joanna. If your question is, so no, you can use the interpreter to run um, existing files, but when we're running CompuCell, no, we won't be using idle. We'll be writing Python code within CompuCell's editor to edit. Um, like I was saying at the beginning of the talk, how we use Python in CompuCell will look a little bit different than how we're doing it today. This is just to teach you kind of the basic concepts behind it. So that when we get to using Python in the CompuCell workshop, you'll have seen a lot of this terminology already. But we'll be using the built-in editor to edit, so it'll look kind of similar to what we're doing here, but it'll be in a different interface. And Python or CompuCell's wizard will create the Python files for you, and then you'll just need to modify those. And then do you need to make your idle file a .py file when you save as? Yes, Haley. That's what indicates to the computer that it is a Python file. Okay, so next topic then is control flow. So this is where we start getting into. So right now we've kind of been using our idle shell as a little bit of a calculator and a printer. But if we really want to start talking about programming more generally, control flow is where it starts to happen. What we're talking about by control flow, this is determining which blocks of code in a program actually get run and in what order they get run. You don't always want everything to run in your program, and you want certain things to be conditional. And we talked about these comparison operators that evaluate a true to false. So we use those as conditions in our control flow statements. So here we refer to this as branching because we get down to a point in the simulation where it's like we say, if this is true, we do this. If it's false, we do this. We skip down here. And then if it's true, all of the expressions underneath the if block get run. And if it's not true, they get skipped. Um, this is easiest to explain through a couple of examples. Um, and this is important to keep in mind that indentation does matter in Python. It partitions different blocks. So when you have a conditional statement or a loop, it's how we represent what's in the conditional or the loop is by what's indented. So everything has to be indented to the same distance underneath the colon. Standard distance is 4 spaces. Usually you just use tab um, to separate those things out. The idle editor will handle some of this for us. So let's go ahead and actually type this in. So again, I'm going to comment all this out. I say if x equals y, and then we have a colon, which represents that we're starting a chunk. And you'll notice that in idle, when you press enter after a colon, it automatically indents for you. So you do not have to indent manually. You may have to fix indentation sometimes if you make certain kinds of edits, but idle will do that for you. So we'll do print x and y are equal. If y does not equal 0. So this is what's called a nested if statement. So we have two different things that can happen. We'll press enter. You'll notice it indents again. Print. Therefore, x divided by y is. And then here's another way to concatenate when you're printing Python as this. You can use commas. And this will automatically parse the result as a string. So x divided by y, and it adds a space as well. So what it's saying is if x is equal to y, print this. If y is not equal to 0, print therefore x divided by y is this. So it's checking to see if y is 0. I'm going to throw a 0 arrow. So let's backspace out. We have what's called an elif. So these are if-else statements. And what this is short for is else if. So this is saying if the first line is not true, now we evaluate for this. If x is less than y, print x is smaller. And now we have what's called our else statement. So this is basically if none of the ifs or elifs are true, we say this. Y is small. And then we can print thanks at the end. This is not necessary, but sometimes it is nice and useful to have a final print statement just to show that you've gotten out of your logical block correctly. Sometimes, especially once you start getting into more complicated programs, you can have logical blocks where it's not clear if it was evaluated properly So having a print statement at the end at least shows you that it got through all of the if else statements. Um, Now, there's one issue with this so far. Anybody point out what this is? What happens if I try to run this right now? X and Y not defined, right? Let's go ahead and run that, and then you'll get an error. We have a bunch of conditions here using the variable X and Y, but we haven't actually given them values. So what we'll need to do is up here above our if-else statements, because again, Python runs each thing line by line. The if statements can only see variables that are defined above it in the program. There are some programming languages that don't necessarily work that way, certain compiled languages where you can define variables different ways that have global access, where the whole file is parsed and then it runs commands. Python is not one of those. Python was traditionally a scripting language, so everything is run line by line. So we need to say x equals, let's see, let's start with them being equal. X equals 5, y equals 5. So we'll save. Now when we run, you'll see we have our conditional where that was met. Move this over here. X and y are equal. And then we have this additional thing. So if it is true, we check to make sure that y is not equal to 0 again, so we're not dividing by 0. And then you can say x divided by y is equal to 1. So let's say y equals 7. We'll run this. X is smaller. Because x is 5, y is 7. So we get to this point, else if x might equal less than y, print x is smaller. And you'll see that it skips the rest of the code. So it's basically just saying, whenever this is true, do this. If this is true, do this. Otherwise, do this. So let's make this 3 just for points of illustration. Y is smaller. Now let's test real quickly what happens if we do make y 0. Let's go ahead and save that. And these, again, in order for this if statement to run, x and y do have to be equal, so x also has to be 0. But again, the problem here is going to be y if it's 0, because it will try to divide and be undefined. So can somebody predict what's going to happen for me when we run this simulation with x and y both equal to, or excuse me, this program with x and y both equal to 0? What is it actually going to print? Yep, they're equal, and thanks. Okay, good. So if we run this, we'll see x and y are equal. Thanks. So this sort of structure specifically helps us avoid things like the 0 error Yash is talking about here, is that we can kind of do a little bit of error prevention this way by making sure that we kind of predict what values we might have if we're trying to do math where something could be 0 in the denominator. There's other ways to do this. There's things called try blocks, which we won't talk about much today because exception handling is a little bit complicated. But we can provide resources on where to learn some of that, where you can put something in a try block, and if you end up with any kind of error, instead of crashing the program, it will provide you some kind of error code and then continue moving on with the program. Very helpful for debugging. Okay, so does that make sense to everybody? Anybody have any questions about that example? Again, I know this may be a review for some people. If you've done any kind of programming, this is pretty basic, but so Dipanjan makes a good point. If X and Y are float type, it is not going into the second loop. I assume what you mean is this else if. So let's give that a try. Let's do 5.0. Dipanjan, you might have a typo because it looks like it's working. Try 5.5 and 7.8. Right. So what's happening here is because x is smaller, so if x equals y, none of this runs if they're different. So if these two values are different, it just skips all three of these lines and goes straight to checking to see if x is smaller than y. So that's what's happening there. It's not necessarily because of their type, it's just because of the logical structure here. Yep, no need to be sorry. Again, if you've never seen this stuff before, it can be a little bit abstract, so no worries. Any other questions? Okay. If you do think of anything, again, feel free to leave it in the chat. We can always circle back around a little bit later. All right. So again, we've talked a little bit already about the difference between assignment and comparison. So assigning it as a single equal sign, that is putting a value into a variable. When you're comparing variables, you have to use the double equals. Um, if we put x equals y with a single equals, we'll get an error. So we can actually see what that looks like. And it won't even actually let us run it. It catches the syntax error, invalid syntax. Maybe you meant equals equals. So just an important thing to keep in mind there. All right, so I'm going to turn things over to you for a few minutes here for a quick exercise. I'll give you maybe 5 minutes. Determine if a number is even or odd. This will give us a little bit of practice, is what we've talked about so far. So choose a number, any number you want, and then depending on whether the number is even or odd, print out an appropriate message to the user. Something to keep in mind maybe is how does an even or odd number react differently when you divide by 2? Once you have that done, you have a couple of extra questions here. If the number is a multiple of 4, print out a different message. And then an additional stretch exercise, make two numbers, one number to check and one number to divide. If check divides evenly into num, tell that to the user. If not, print a different appropriate message. So I'll give people, let's put 5 minutes on the clock here. You can take a couple of minutes to take a look at this, and then I will, maybe in 2 or 3 minutes, I will start coding it here for us. And feel free to ask questions along the way. Yeah, just a couple minutes left here. Has anybody gotten that first point already? Just checking if it's even or odd and printing out the message. Irina good, Suvani good. So what's the method that you use to check and see if it's even or odd? Suvani, okay, good. Looks like people are getting the point. If you divide by 2, you should get 0 or 1. If it's 0, that means it's even. If it's 1, that means it's odd. So does somebody actually want to share their code in the chat? Good. Hey, Katerina, I like your very literal print statement for multiple of 4. Okay, good. So it looks like people are getting this right. So actually, Chimizi, am I pronouncing that right, Chimizi? You can let me know. Just going to grab your code here and drop it in. Oh no. Formatted it as all one big line, so I'll have to do this manually quickly. Let me change this to x equals 4. Oh, sorry. Okay, there we go. And I'll go ahead and give this a quick run. X is an even number. Now if we change to 5, run, X is an odd number. Good. Okay, good. So looks like people are catching on pretty quick. Good to see. I will go ahead and leave these extra exercises up to you if you'd like to work on them later this week. Um, then that's great, but in the interest of time, we'll skip the rest of the example today because I think people are up to speed here. All right, so the last thing we'll talk about before lunch is loops. And then when we come back from lunch, we'll finish up talking about um, sequence types and slicing sequences, defining functions. Um, and then we will work through as much of our blackjack example as we can. Um, okay, so the next piece of control flow is loops. So we've been looking at branching here with if else. But the other component of control flow is looping. So running the same portion of code repeatedly until some condition is met. So I'm going to, I keep having to move the Zoom controls back and forth. Actually, no, when I'm screen sharing, I can't hide it. Okay. And what I'll do when we're finished with the module here is I'll go through and give these all titles so we remember which example is which, and then we'll upload this file for everybody to reference later. There's 2 different kinds of loops, while loops and for loops. First, we're going to talk about while loops here. So in this case, a while loop runs until some condition is met and it evaluates the code underneath it until this condition becomes false. So while it is true, it runs. And then once it becomes false, it will stop. And it checks the condition at the beginning of each iteration of the loop. So each time you run through, it double checks the condition. This is best seen using an example. Um, sorry, we'll have an example in a minute. It looks like yeah. So n equals 0 while n is less than 5, print n and n plus 1. So let's go ahead and actually just type that in here. So n equals 0 while n is less than 5. So again, this is using our conditionals that we were talking about before. Print n, and then here we have to have some kind of incrementer because our condition is n is less than 5. If we don't have an incrementation line that will increase the value of n, what ends up happening is the loop just runs forever because the condition never becomes false. That's what's called an infinite loop. These can be frustrating at best and dangerous at worst. So it is important to make sure, especially when you're using while loops, that you always have some sort of condition in your loop that will ensure that the loop eventually becomes, or the loop condition eventually becomes false. So let's do n plus equals 1. Again, this is the same as n equals n plus 1. So we'll go ahead and save. And now, sorry, meant to grab the zoom controls there. Now when we run our module, it will print out our values. Now you'll notice something a little bit interesting here in that it starts at 0 and stops at 4. Can anybody tell me why we don't print out the value of 5? Because n is less than 5. Index starts from 0. Good point. And yes, Yash makes the point that if we did n is less than or equal to 5, it would print it. So if we do less than or equal, the condition changes here. Basically what was happening when it was just less than is that once n becomes 5, so we get up to 4, print 4, n plus equals 1, n becomes 5. Now when it checks the condition, this is false because it is not less than 5, it's equal to 5. So it does not do what's in the while loop. If we do less than or equal, though, it will evaluate it again and be like, okay, it is equal to 5. Let's run it one more time. Then it will be n plus equals 1. N will become 6, and now it's greater than 5. So when we run this now, we'll see it prints all the way up to 5. So relatively simple example. Similarly to our if statements up here, we can have a nested if within another if. We can do the same thing with loops. We could have multiple loops run within each other, and we'll look at an example in a minute of how that works. The other kind of loop that's common in most programming languages and that Python has a version of as well is the for loop. So the for loop in Python is specifically intended when you're iterating over a list of things. We can shortcut our while loop here with a for loop. So saying for n in range 5. What this range function does is just creates a range from 0 to 4, I believe. 0 to 5. We'll find out when we print it. And then we print n. So what this is doing is just saying we have this range from 0 to 5. For n in range, we print each value. So it's going to say, it's going to start at 0, print the value in that spot, and so on. So let's go ahead and run. And here, sorry, I should have cleaned this up a little bit. Let's do print for loop. And then we'll add up here. Print. Okay, now save and run. We've got our while loop that runs through 0 to 5, because again, our less than or equal to condition, and then our for loop actually stops at 4. So our range value does create a range of 5 slots, but n starts at 0. So we've got 0, 1, 2, 3, 4. For loops, again, are very common for iterating across lists. Anything that has any data type that has basically slots in it that can hold values. We'll talk more about that in a few minutes. But for loops are also safer because they have a definite range. So again, with the while loop, you can end up with an infinite loop situation because of logic that never terminates. For loops run a specific number of times. There are some conditions where you can get a for loop to run forever if you do some kind of wacky stuff in your expressions within the for loop, like if you're adding length to things. But generally, for loops are a lot safer because they will automatically terminate at the end. It's much harder to get an infinite loop with a for loop. Not necessarily impossible, but very difficult. Again, so this runs over a sequence of things. The variable, this is a temporary variable that's only instantiated for the for loop. It takes a value, starts at the smallest, gets the next value in the sequence, and moves on. The for loop is a little bit harder to get your head around than the while loop just because of how Python kind of structures them, but we'll look at some more examples. It should become clear as we move forward. So again, this range function creates a range of values using start, stop, and step. So here we said range 5, which just tells us how long we want. Starts at 0, and the step is 1 if it's not defined. But we can specify certain values if we want. So if we say, sorry, there we go. So let's take a look at this. My sum equals 0 for I in range 7 to 10. And you'll notice in idle, we get some of these useful pop-ups, and we use built-in Python functions that will remind us of the syntax that we need and what parameters it takes. So up here we specified 1, so it used the default start value of 0 and the default step size of 1. But if we specify 2 values, that's our start and stop. So it starts at 7, ends at 10. My sum plus equals I. And then we want to print my sum. Comment this out so we don't have a bunch of other stuff being printed. Now when we run this, our sum is 24. If we wanted to print out each time, we can do print so we can see what's actually happening in the loop. And then we can say final value, comma, my sum. So let's run that again. We can see the loop runs 3 times because again, it starts at 7, so it's running 7, 8, 9, 7, 15, 24, final value 24. And here we're starting at 7, and then it's adding, sorry, we're starting at 0, and then it takes the value in the range that's currently sitting at I, adds it to my sum. So first it adds 7, next it adds 8, then it adds 9. and then it finishes because it is finished running through the range. Here we can do a similar example. So I'm going to copy and paste this code, but let's say we want to specify start, stop, and step size. Let's do 5, 11, and 2. So it's going to start at 5, end at 11, and now it's using a step size of 2. So what does that mean? Can anybody tell me what a step size of 2 instead of 1 means when you're creating a range? Yes, it will increase I by 2. Right. And I'm actually going to add numbers to these just to keep things clear. So let's go ahead and run this. We can compare the two. So so actually what we can also do is helpful. So we can actually see what's happening here. We can print out I, and then we can print out the sum. So this is a very common debugging strategy, is to put print states in your loop so you can actually see what's happening. Because if we just look at the total, we can kind of backwards deduce what's happening, but it takes a minute to really think about what's going on, and it introduces potential mistakes. But this way, it just makes it very easy to check and see what's going on. So let's go ahead and run these. And you'll notice here I can reuse I because again, the I value is only exists basically during this for loop. Once we're finished with the for loop, the I variable is cleared and can be used again. Let's go ahead and run. And we'll see in our first for loop, we start at 7, I equals 7, I equals 8, I equals 9. Here you'll see I is 5, and then like people were saying, you jump by 2. So our step size is 2, so we start at 5, add 2, 7, 9, until we get to 11. And again, for loops are indexed non-inclusively. So once we hit 11, that's considered the end of because we start at 0, or not at 0, but we started our first index. Our final index is not included. Okay, so that's the range function. We are almost to the end of this section. So what I'll do is go over break statements, and then we can come back. I'll leave this problem on the screen when we go to lunch so people can work on it if they'd like to. So break statements, this is last thing we'll talk about with loops for now. If you would like to break out of a loop, for example, if something is true and you need to leave the loop and not evaluate the rest of it, you have break, which will end the loop. An important thing to keep in mind is that it only breaks out of the innermost loop. So in this example, it will stop before expression B, but then it will still run. It'll still continue to run the larger while loop. We have an example here. So we have a condition where if the sum equals 5, we break out of the loop. So you can, over the lunch break, you can copy paste this into your program and kind of see how that works. I don't want to take too much time from lunch from people. A couple of notes on for versus while loops. Again, we know the exact number of iterations in a for loop, so it's much harder to end up with an infinite loop situation. You can end early via break. You can do that for both of these kinds of loops. Um, for loops inherently use a counter. Um, while loops can use a counter, but you have to initialize it before the loop and then increment it inside the loop. So this gives you a little bit more freedom as to how you actually track things. But again, you have to be careful that your conditions will reach a state of being false at some point, so you do break out. Um, you can almost always rewrite a for loop using a while loop. The syntax will be more complicated for the while loop, but you can almost always accomplish for loop conditions with a while loop. But you may not always be able to rewrite a while loop using a for loop because, again, for loop, you have to have a set number of iterations. For while loops, they're most useful when you don't know how many times a loop needs to run. You just need to run until a certain condition is met. All right, so like I said, I'll leave this on the screen if people want to work on that during our lunch break. We are 2 minutes into the lunch break here, so we'll come back at 1 o'clock for finishing off this module and then getting to our blackjack example. The rest of this module should only take about half an hour. So thank you everybody for bearing with getting idle up and running at the beginning. I know we ate up some time with that, but I wanted to make sure everybody was able to follow along today. Um, so if you do not have any questions, feel free to go ahead and go to lunch. Um, and we'll come back here at 1 p.m. Eastern Daylight Time. I'll put a slide up in a few minutes reminding people. You can either leave the meeting and come back, or you can just leave the meeting open. Either way is fine.